Assalamualaikum. My name is Natra binti Muhammad Qayyum Jeffrey and my student ID is 2019409528. So today I will going to present chapter 5 about heat. Are you guys ready? Let's go. So firstly, do you guys know what is temperature? Temperature is a measure of average kinetic energy of individuals molecules, or a measure of how hot or cool something is, or is the degree of hotness and is a degree of hotness of an object. So what is SI unit for temperature? SI unit for temperature is Kelvin, which is capital K, or others is degrees Celsius and degrees Fahrenheit. So here I attach the thermometer that we actually use in lab. So we move on to the serious part. I hope that everyone can focus for this part about conversation of unit that used in this topic. The conversation between both scales can be given as three equations. For first equation is about degrees Celsius, second is about degree Fahrenheit, and lastly is about Kelvin. As we move to the example 1. A healthy person has an oral temperature of 28.6 degree Fahrenheit. What will this reading be on the Celsius scales? So the question states that 28.6 degree Fahrenheit should be changed to Celsius scales. So what actually you want to use? They have three equations, so which one we want to use? So we should use for the first equation. What is the equation? The equation is temperature degrees Celsius is equals to 5/9 temperature degree Fahrenheit minus by 32. So 5/9 28.6 minus 32, and we will get 37 degrees Celsius. So let's move to thermal equilibrium. So what is actually thermal equilibrium? Equilibrium state that at rest. So two bodies are said to be in equilibrium if they are at the same temperature, or we know as constant temperature, has same kinetic energy, constant kinetic energy, and lastly no exchange in thermal energy between two bodies. That this object in thermal equilibrium, we state if you have two objects in different temperature. First is cool and other one is hot, and this show that this object have kinetic energy in different value. So because they are close together, this can make heat transfer from hot to cold. At sometimes they will reach at the same temperature and kinetic energy. So at this point we can say that the object is successfully achieved the thermal equilibrium. So next, what is heat? Definition of heat is energy transferred from one object to another object because of difference in temperature, cool or hot. Heat is transferred from hotter object to a colder object. So heat is actually moved from hot to the cool object. So heat can be measured in unit of calorie, kilocalorie, or in commonly used is joule. Oh yeah, before I forget, this heat can be measured by using calorimeter or joule meter. So this is the last part of my slide about the conversation between both unit that we actually use in this topic, heat. Heat is measured in calories or joule. 1 kilocalorie is equals to 1000 calorie. 1 calorie is equals to 4.186 joule. 1 kilojoules is equals to 1000 joule, and the last one, 1 kilocalorie is equals to 4.186 kilojoule. That's all from me. So now I will pass this session to Hafiz to continue about calorimeter.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Hafiz bin Muhammad Pini. I am from class AS12025. My ID number is 2019247346. Today I want to present you about calorimetry. What is calorimetry? This is calorimetry. For example of calorimetry is a polystyrene cup. Okay, what is calorimetry? Calorimetry is a diffusing heat and thermodynamic, often to refer to the particular system. There are three types of system, which is closed system. No mass will enter or leave, but the energy will be exchanged. Second one is open system. Mass may be enter and leave, same as the energy will be transmit or leave. Third one is isolated system, which is no energy will be transmit in any form of energy. So, what is the problem in calorimetry? But first, we need to remember the equation of calorimetry, which is total heat loss is equal to total heat gain. When the different parts of any object is isolated in isolated system at the different temperature, heat will flow or heat will be transferred from any parts of objects at higher temperature to the lower temperature. This process will continue until both of part of object reach the stage of equilibrium. So, when at this stage, the final temperature for both parts or object in the system are same. To solve any problem at calorimetry, the concept is the conversion of the energy will be used, which is the equation that I said first. Which is total heat loss is equal to total heat gain. So, remember the thermal equilibrium that we learned that last part, which is two objects in a different temperature put in the contact, then the heat will transfer from hot to cool. Then the object will be same temperature.
Hi guys, my name is Norabiha Akila binti Yusof. I'm from AS12002 Group 5 from USM Tapapera. So today we're gonna discuss about the specific heat capacity. Okay, so let's go. So what is the meaning of the specific heat capacity? Okay, it means that the amount of heat that required to raise the temperature of 1 gram substance by 1 degree Celsius. So, to learn more, I hope you guys watch the video that I have provided for you in the next video. Let's go! Welcome back in this video. So I hope you guys understand what I have told you, some information of the specific heat capacity in the video a while ago. That's all from me. Thank you. Bye bye.
Hi, Assalamualaikum. My name is Nufa Ikam Tizazif Hafiz, and I'm going to continue with the latent heat and change of phase. Okay, so latent heat. Latent heat is the thermal energy required to change the phase of a substance by a given mass m of a substance without no temperature change. Okay, there's two types of latent, which is latent heat of fusion (LF) and latent heat of vaporization (LV). Okay, both means by the quantity of heat required to change a unit mass 1 kg of a substance. But for the heat of fusion, it is from solid to liquid, and for the vaporization, is from liquid to gas. Okay, and then as you can see here, this is where the ice. This is ice, and then here, why the temperature is constant? The temperature is constant because this is where the solid is becoming liquid. So in this phase, there's two phase, which is solid and liquid. This is where the latent of fusion occur, and then when it comes to here, it is fully liquid. So when the liquid is boiled, the temperature becomes constant again, because of this is where the latent heat of vaporization occur, which is making this phase has two phase, which is liquid and gas. And then when all of the liquid turns into gas, they go into the boiling point of gas, water, which is 100 degrees Celsius. Okay, then I want to give you an example question. This 50 gram of ice at 0 degree is placed in a thermos bottle. Please bear in mind that thermos bottle is we're using thermos bottle. The heat will not exposed to the surrounding, so the heat is kept in the bottle containing 100 gram of water at 80 degree. What is the final temperature of the mixture if all the ice melts, which is in equilibrium? Okay, so the given latent heat of fusion is 3.33 multiplied by 10 to the power of 5. Okay, why heat of fusion? Because it is the transition of ice to water. Okay, specific heat. This is specific heat of water, 4,200 kg degrees Celsius. Okay, so the solution is we get that ice M is 0.05 kg, C the given, and T delta T is T minus by 0, and water M is 0.1, C 4,200, and delta T is 80 minus by T. Okay, so Q loss is equal to Q gain. Q loss is water and Q gain is ice, because the heat from the water is given to the ice, so that ice melts and achieve the equilibrium, both of them. Okay, and then the equation is MC delta T is equal to MC delta T plus ML. L in this equation is LF, because it is the transformation from ice to water, so it is latent heat of fusion. Okay, so the M is just put in the equation, all the information that we got from the question, and we got that T is equal to 26.43 degrees Celsius. Okay, I think that it is for latent heat and phase of change. I hope my explanation is clear enough for you to understand this subtopic. Thank you.
Hello, Assalamualaikum. My name is Rafika binti Osmera. I'm from AS 1202 Group 5. So today I'm going to present about the heat transfer mechanism. So first thing first, I will tell you guys the definition of heat transfer. Heat transfer is the movement of heat from warmer object to colder one. So there are three forms of heat, which is conduction, convection, and radiation. I will explain more about conduction. So the definition of conduction is the process whereby heat is transferred directly through a material with any bulk motion of the material playing no role in the transfer. Atom and molecule in hotter part of the material vibrate or move with greater energy than those at cooler part. Two objects at different temperature are in contact with each other. Heat flow from the warmer to the cooler object until they are both at the same temperature. For example, if we warm our back muscle with a heating pad, the heat from heating pad being conduct from heating pad to our back muscle. So our back muscle will become more hotter. So the second example is when we iron our skirt, the iron is hotter and the heat is transferred from iron to the skirt, so we can iron the skirt easily. So this is the list of thermal conductivity. Material with large thermal of conductivity are called conductors. Those with small k are called insulators. The second part of heat transfer mechanism is convection. So the definition of convection is heat flows by the mass movement of molecules from one place to another place. It may be natural or forced. For example, if we boiling water, the heat passes from the burner into the pot, heating the water at the bottom. Hot water rise and cooler water move down to replace it. It causing a circular motion. So this is the example for convection. The last part of heat transfer mechanism is radiation. Radiation is the process which energy is transferred by means of electromagnetic wave. It is the rate of heat transfer through emission or absorption of electromagnetic wave. Emission when electron return to energy level, while absorption when electron gain energy and jump to higher energy level. So this is the example for radiation. Radiation is that it is how you can feel heat without touching. You can solve the question about radiation using this formula.